Welcome to our explainer on coordinate geometry. We're going to take what looks like a super complex map of points and lines and show you how to turn it all into a simple, solvable puzzle.
I mean, that's the big question, right? Coordinate geometry isn't just some abstract thing you see on a graph. It's actually a really practical way to describe the world around us, and all it takes is a few numbers and a couple of rules.
So let's just dive right in. We're going to build our problem-solving kit from the ground up, and by the end, you're going to have 3 essential tools that'll let you tackle pretty much any coordinate geometry challenge thrown your way.
All right, our first tool is a real fundamental one. It's all about finding the exact center of any line segment, and it doesn't matter where the endpoints are.
Just think of it like the perfect halfway point on a road trip between 2 cities. It's that single spot that's the exact same distance from where you started and where you're going. It perfectly balances the 2 ends.
And you know, the beautiful thing about this formula is just how simple it is. You're literally just finding the average of the x values and the average of the y values. That's it. And that gives you the exact coordinate of the middle.
Okay, so let's try it out. For our x-coordinate, we do 1 plus 7 divided by 2. That's 8 over 2, which is 4. For the y-coordinate, we've got -3 plus 2 divided by 2. That gives us -1/2. So the exact midpoint is 4, -0.5. See? Simple as that.
Next up in our toolkit is a way to measure how steep a line is. Now, you might have called it the slope before, but mathematicians have a more specific term for it, the gradient. And this single number is actually incredibly powerful. If it's positive, the line is climbing uphill from left to right. If it's negative, it's heading downhill. And the bigger the number, the steeper the line. It tells you so much.
And here's the key part. This formula, just the change in y divided by the change in x, tells the entire story of a line's slant, all in one neat little number.
Let's calculate it for our line then. The rise is 2 minus -3, which is 5. The run is 7 minus 1, which is 6. So our gradient is 5 divided by 6. And since it's a positive number, that tells us, correctly, that the line is going uphill.
Okay, on to our third tool. This is where we see how that gradient idea actually defines the whole relationship between 2 different lines. It's kind of like the geometric rules of the road.
And here are the 2 fundamental rules. For parallel lines, well, they run in the same direction, right? So it makes total sense that they have the exact same gradient. Perpendicular lines are a little more clever. Their gradients have this cool property where they multiply together to give you exactly -1.
So let's use this rule to solve a problem. We're told these 2 lines are parallel, which means their gradients must be equal. Okay, first things first, we need to get both equations into that familiar y equals mx plus c format. For the first line, that gives us a gradient of -1 over a. For the second line, its gradient is 2 over 5. Since they're equal, we just set -1 over a equal to 2 over 5. A little bit of algebra, and we find that a has to be -5 over 2.
All right, it's time to combine our tools. We're going to tackle a classic multi-step challenge that uses everything we've learned so far, finding the equation of something called a perpendicular bisector.
You know, the name really tells you everything you need to know. Bisector means it cuts the line exactly in half, so it has to pass through the midpoint. Perpendicular means it crosses at a perfect 90-degree angle. So this is really a 2-part problem that needs 2 of the essential tools from our kit.
Now remember, to define any line, you really only need 2 things: a point it passes through and its gradient. And our toolkit gives us the exact methods we need to find both of those key ingredients for our perpendicular bisector.
Okay, this is where our toolkit really gets to shine. First up, we use the midpoint formula to get our point. Bam, it's 4, 7. Second, the gradient formula tells us the original line's gradient is a nice, clean 1. And finally, our perpendicular rule kicks in, telling us the new line's gradient must be -1 because, well, 1 times -1 equals -1.
We've got everything we need now. We're just going to plug our point 4, 7 and our gradient of -1 right into that standard line equation, y equals mx plus c. All that's left is to find that final piece of the puzzle, the c, which is the y-intercept.
And there we have it. After a few quick steps of algebra, we find that c is 11. This gives us the complete final equation for our perpendicular bisector, and we solved it from start to finish using just the tools from our new kit.
And just like that, you've put together a really powerful and versatile set of tools. With these core ideas, the midpoint, the gradient, and the rules for parallel and perpendicular lines, you have a complete system for navigating the geometric world on a coordinate plane.
And that's our explainer. We've built the kit, but the real question now is, what are you going to build with it? Maybe you could prove a shape is a rectangle or find the dead center of a circle. Now it's your turn. Go put that new toolkit to the test.